Welcome back again. Sorry, I just took a small break before I start. Very important topic and very interesting topic, I will say, is the concept of fine-tune versus low-rank adapter. So in AI world, there is something called fine-tuning your LLM and something called use LoRa adapter. So fine-tuning uh, is more about like doing some painting work uh, of your entire house versus LoRa adapter is just adding some external component which is already there in your means already created a house. You are adding something additional component that's called low ranking adapter, LoRa adapter on the right hand side. So the it is not fine tuning is not full training. Remember, full training, which we talked about in earlier slide, is constructing the entire house from the scratch, which will cost you million dollars. But fine tuning is like putting some color change, and you're getting some brand image, brand styles and those things. If you want to do it uh, for your LLM, that's where you can use fine tuning. And if you want to add a very specific component to your LLM, so it will cost you very less compared to fine tuning, which will be around like 50K dollar. Whereas if you do add a use a LoRa adapter, it will cost you around like 50 to $500 only to add that extra thing to your LLM. So that's the two concept, and when to use what we'll definitely going to talk when we go to the decision path, CEO decision path, where we'll cover those things. But here I want to just cover the concept between fine tune versus lower adapters. This image tells you the same thing. This person is trying to attach a small component to your house. Is that's the same thing? You're putting low ranking adapter in your LLM. So behind the scene, when you do fine tuning, it's more or less you adjust all most of the weights uh, for already existing LLM. So it will cost you more, not like full cost, but at least uh, in the range of like $50,000. Whereas if you do LoRa, is basically you add a very small adapter to it. So basically you are adding a certain matrix at the thin layer, and then uh, ensuring it works with your uh, model. So this is how it done at the model level. So your base model is frozen, you don't touch that, just you add an additional matrices to it and then create the output for it. Okay, next is something called distillation in LLM world, where what you do is you use large LLM to generate output uh, uh, for a custom queries. So let's say you are in, let's say, in the construction industry, and you want to get some specific information and correct information out of it. You write a lot of questions, give it to big LLMs like Fable, and it gives you output, that generated output. You use that as a training set to create your small LLM. So you have a small LLM, you create out of it, and that you can do it in the range of like 20,000 to 150,000. You create your own custom small LLM, which was the case in originally also. This is how most of the LLM providers do they also create similar like for example IQ, or other things. Small LLMs are derived from the bigger LLM by generating very specific kind of thing, output. So this is how we can think about, like LLM is like somebody who have a very extensive knowledge about most of the things that that person will train other uh, professors, and they will whatever they have learned from that, and they will implement. Uh, so when you do this, the idea is your small LLM is know to do that particular task very nicely, because it has learned from the large LLM, and can do that specific tasks, in very low cost. It doesn't have to run the full, all the big weights, and it can do efficiently and accurately. So that is the advantage of distillation. Uh, we can use this kind of thing uh, in your corporations as needed. So that's the concept of distillation. And then one more concept. I'll go to this first. Let me cover the distillation, what is happening in the back end. So distillation is like you use the large model on the top, which generates the probability logics, where you can use those things to train your small LLM, which will be, here back propagations will be involved, but it will learn from the information it will use is from the output generated from the model. So it has a very specific, uh, you know, weights get adjusted and more efficiently of creating this small model from the big model. Okay, let me go to the next one, which is called speculative decoding. I know the word is a little complicated, but the idea is very simple here. What you do is you use your small LLM, okay, small LLM to do the task, whatever the task, and it generates that output and send that output, combined output, to large LLM to check if whatever they have created the output based on all the questions and answer, the large LLM will check if this small LLM has done correctly or not. What is the advantage? Advantage is a the large LLM don't have to do all this multiple reading and generating output for each, versus it has to just read the input and only generate pass and fail. Wherever it is fail, generally it will be less, it gives the recommended output. So overall cost will again 2 to 3 times cost saving with this approach we get. Now the word speculative decoding comes from the idea whatever the small model is generating is speculating. It's actually speculating it is right. Okay, it is right, but that will be reconfirmed with large model whether it's or not. So hence the word speculative decoding. Okay, so this is the same image, it is depicting that. And if we want to see it's what is happening behind the scene is, if you send everything to the large model, is definitely going to give the output, but it's very expensive. Instead what you do is you send it to this small LLM, it will generate the output, and that output you verify with the uh, large model. So overall cost will be reduced because it doesn't have to do this initial work of creating the things, and it is more about just validating, and it can do more read in one go, and the cost will be less, and the output at also it can provide in very small like yes or no, reject, accept kind of thing. Again, the output token will be less, so overall you achieve 2 to 3 times less price. It's very nice idea. Speculative decoding, and same as distillation, is also very nice idea, concept. Even LoRa is also very nice concept. So these are the techniques. If it is not there in your organization, if they are not using it, the you can suggest from case to case basis. You can suggest and start implementing. It will save money. Okay, I'll go to the new another topic which is totally different one, which is more about uh, whether you want to you, buy your own GPUs, and instead of using the cloud services, you you bring your whole you install those LLMs into your own GPUs and run it locally. Whether you want to go for that or not is uh, something you, if let's say somebody like a CTO has proposed to you that we want to do a in-house buying of GPU and use that because it is less expensive versus using any cloud services. The one critical aspect we have to remember, that if you are not using your GPU more than 50%, hmm, then you should not go for self-hosting, because you you are underutilizing your infrastructure, and then you have to definitely pay for your depreciation, everything. You are going to bear it if you self-host it. So that decision, generally there is a recommendation you check whether the GPU utilization in your API per use, basically if you're using external API, whether there are you using the GPU for more than 50% of time. If answer is yes, then do further analysis and take that decision of self-hosting. If it is no, it is mostly recommended to use external vendors for hosting your LLMs, uh, like cloud providers are there, right? It will cost you expensive, but you may not be using that much of your uh, API calls. So the same idea here. If you're staying for a short term, it's good to you stay in hotel. It will charge. But if you are going to stay for longer time, buying buying your own things is less expensive than staying in the hotel. So that's the image is trying to depict. Okay, it's very logical question, but this is the same thing applicable for if you want to use GPU in-house or versus outside. Okay, now same idea. How much you are utilizing your GPU? At the if your GPU is not fully utilized, there's no, it's like a waste. Okay, now I want to go to not this right now. I will go to the slide, ending slide, which is very interesting to talk about. Uh, so as as a CEO, you may have here all these things on the left hand side, and what all things you can do to reduce the cost. That's this slides talks about that. Now, very basic question: whenever your expense is growing, okay, so the most important thing you should ask to your engineering teams or technical pro team: do you have a dashboard anywhere which captures workflow, important word, workflow wise cost, because you don't want to note, okay, token cost, this much token I'm spending, this much is over, but you want to divide that by workflow, divide by the tasks, how much is my money is going by workflow, because that's where you will know, because workflow will tell you how much you are value you are generating from that workflow, what is the cost for it. So this is the step 0, which is, I will go here, that you should ask it, do you have a dashboard which tells you what is the cost per workflow? And typical dashboard, that's what I want to show you, which will look like in the case study, which this is our typical dashboard will look like uh, for your workflow. So for example, here, this is a hypothetical company where total spend is around 847 monthly spend, okay? And this company is a size of like 10 billion cap. So let me go there quickly. So 10 billion market cap company, and its revenue is around 12,000 employee, and they are spending around 80 per month on AI spend, okay? They they are using the big model 91% time. They have not kept any agents, no cash disciplines. So basically, arbitrary situations has been created uh, to 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 give you an example what is happening, and why, how much you can benefit if you follow, if you use all this leverage which you have just gone through. You can actually decrease your cost almost half per month within 4 months of time, uh, if it is properly, without losing your uh, our value you're generating from it. So this is a typical company. So if that is the company, and what a typical workflow will look like, say you have a support agents that's uh, calls multiple times, it's like 9 for per task, it is spending around 9.2 calls. So how much cash is used, those kind of information that dashboard should provide. There is another workflow which is like reviewing any contract. Are we, when you're reviewing a contract, you are fulfilling, putting all the entire PDF into LLM, instead of you have a vector database where you put it all this PDF and then put it, that will reduce your cost. Here there is a research assistant, somebody in your team, they are using it to research, but they have kept it everything on max reasoning. uh, is it necessary to keep everything in max reasoning? That is also you should question. Although it's a research team, you will find there are opportunity, it's not needed for everything for reasoning. Same goes for, there is an HR policy bot which doesn't use any cache mechanism. Every time it's putting all the system prompt again, kind of a waste there. So there is also another sales ops agents which spending 7.1 calls per task. So we have to check if there is this much calls are needed, or it can be reduced, number of calls per task. Those are the things we can investigate. So to do any exercise, you fundamentally need some information like this uh, by workflow. Okay, you get this information from your CTOs to begin with, and then you can further drill down and questions and improve the overall system. Now I will go back to the main things again. So this is the first steps. We will need to ensure you have a dashboard to view the cost. Okay, once you have a visibility, and the rest of the things you can do. Okay, so you can start asking the question: is the huge prompts same policy every call? If you are using that kind of thing, use prompt caching. Okay, if your team is feeding PDFs and directly into the chat, you'll know, okay, they are not using vector database. You can ask them to do that. If everybody, most of your teams is using large LLM instead of using small LLM, they don't have a model routing mechanism. There you're spending too much money, so that you can reduce. There will be case where you can create a small LLM out of your large LLM, which is called distillation, uh, from your private data, which is you create your custom LLM and then implement in your workflow, in your process pipeline. You use that, so you can actually reduce the speed. You can increase the speed of processing as well as accuracy by distillation. So distillation is something I I personally like it, but there is because you can use your personal private data uh, pri- for getting very refined answer. So this is the area I think we can explore for your process pipeline. Now there are other basic things like common sense thing. If there is simple tasks, why you need agent? You don't need agents. So for even for the simple tasks, people are asking agent to do something. There you can cap it. You can you can put that instruction. Similarly, don't use every time reasoning, because reasoning is always expensive. The other concept is you use large model to verify the small ones. This is speculative decoding, which we talked about. Uh, this is another very nice. Most of the company may not be using it, but this is a very nice. Uh, Based on your own company structure, what kind of work you're doing, you can use this speculative decoding. Very I personally prefer distillation, and speculative decoding is a nice way to reduce the cost given the current condition. Then if somebody from your organization saying and coming for, let's say, I want to do fine tuning, just avoid that, because fine tuning is not always needed. You can use low rank adapters, which is like spending around $500 versus $50,000. You will save a lot of money. Fine tuning is more expensive, will cost you too much, and unless it's absolute necessary, like you want to create your whole new branding kind of LLM, you want to spend it extra money, then only do for it. Otherwise you can solve it using low rank adapters, which is basically your so for example, instead of re uh, construct doing an entire rework of your house, just put a simple hook in your house. That solves the purpose. uh, if your technical, this is for GPU, if your technical team comes and say that we should go in-house, so first thing you should ask, prove me whether you are using your GPU more than 50%. If the answer is no, you don't go for it, because you're going to spend a lot of money in your depreciation cost for GPU. And yeah, the technology is evolving fast. Another new GPU will come in the market, which will have a higher memory bandwidth and higher processing speed, etc. Your asset will depreciate really fast. So generally avoid this self-hosting. And finally, after implementation, uh, obviously you want to see, is this impacting your P&L? Expense has dropped. You want to track it. So that's very common sense things to do it. All right, I think this is pretty much, I want to end with it. So idea is basically, if the team cannot show workflow, you have to ask them to have a dashboard, give them dashboard. ask them to create a dashboard for it so that you have a visibility. And once you have the visibility, you can use this approach to solve it. All right, thank you so much.